Today to solve logarithmic and exponential equations. These properties are already in your notes, so you don't need to write them down. I just want to highlight this is the one-to-one property, where if your bases are the same, then your exponents equal each other. Same thing here, one-to-one property, your bases are the same, so then your x's and y's equal each other. The next two are your inverse properties. Log base a of an exponential base a, it just equals x. Or an exponential raised to a logarithm of base a, it also equals x. We also have these properties where if you have a multiplier, you can split it up as addition. If you have a divider, you can split it up as subtraction. If you have a power, you can bring that power down in front. And then sometimes we want to convert between the two forms. Here is logarithmic form, and then here is exponential form. So here's our first set of examples. Example A, 2 to the x equals 32, and we want to find out what x can be. One process you can go through is you can rewrite the right-hand side to the same base. So I say 2 raised to the 5th equals 32. Then I use the one-to-one property. My bases are both 2, so then that means my exponents must also equal each other. So x equals 5. Example B. I have a natural log of x minus the natural log of 4 equals 0. I can combine these two logarithms back together. When there's subtraction, you can divide them, or you can bring this term over to the right. So it wouldn't benefit us to go natural log of x over 4 equals 0. That wouldn't help us. I'm going to erase this. Another property we can do is move this over to here. So the natural log of x equals, now we add the natural log of 4 to each side. The one-to-one property says I have a natural log of base e, those are base e's, then x must equal 4, one-to-one property. So x equals 4. Next example, 1/3 raised to the x power equals 9. Very similar to our first example. I can rewrite these to the same base. So I have 1/3 x equals, and I'm going to just go ahead and rewrite this as 3 times 3, which is 9. Then, if you remember, a fraction, 1/3, can be rewritten as 3 to the negative 1 power. And I still have an x out in front, out on the back side here, and then 3 squared. Now I have a power to a power, so I can multiply those two pieces together. Negative 1 times x is negative x. And then I have the 3 equals 3 squared. So I've converted them both to the same exponential base 3. Now I can use the one-to-one property. Exponents must equal each other. And now I solve this equation for x. So we divide both sides by negative 2, and I get x equals negative 2. Come back up to this example. Question D. We can use the inverse property. This is a base e. The inverse of an exponential base e is a natural log. So if I natural log both sides, so increasing both sides by the natural log, these two pieces are inverses of each other. So it drops out, and you're just left with x equals the natural log of 6. Then you can use your calculator to enter that in. So if you wanted an exact form, you'd leave it as a natural log of 6, or in your calculator, a natural log of 6 equals approximately 1.792. So either answer there would be acceptable. Next example, E. We can use the inverse property again. We can raise both sides to an exponential of base e. The reason why is these two our inverses of each other. So you're left with x. And then on the right is just e to the negative 2. Now again, you can use your calculator. If you want to rewrite this as x equals 1 over e squared, you could do so. So 1 divided by e squared is approximately 0.135, or in exact form, just leave it as x equals negative e to the negative 2, or x equals 1 over e squared. So any of those answers are acceptable. Example F. Again, we can use the inverse property. I have a logarithm base 10. I can raise both sides to an exponential base 10. You have to do to both sides. These two pieces are inverses of each other, so you're left with just x equals, and then on the right it's 10 to the negative 1 power. I have a negative power, so that's 1 over 10 to the positive 1, or just 1/10.